The next thing we'll learn is how to prepare isotonic solutions that contain more than one component. So if we have a problem where we want to make 1 liter of an isotonic solution, and this time it's not only using NaCl, but we have 10 grams of drug in the solution, then how many grams of NaCl should be used, and how would we prepare it? Well, we could start out by putting our 10 grams of drug into the container, and we would use the E value to ask how many grams of NaCl would this represent in solution, like how many particles of NaCl would this represent. So we would do that by multiplying by the E value, and we would see that the 10 grams of drug with an E value of 0.2 equals 2 grams of sodium chloride. And so instead of just adding 9 grams of NaCl like we normally would to make 1 liter of isotonic solution, we would only need to add 7 grams of sodium chloride because 2 grams are represented by the drug. So we could add 7 more grams of NaCl, we would add enough water to get to the 1 liter mark, stir it up, and we have our isotonic solution that contains drug and NaCl. So we can apply the process that we just looked at in the picture to a real problem. The first one asks how many milligrams of sodium chloride should be used in this prescription. Let's take a look at the prescription first. The prescription says that it contains 0.35 grams of ephedrine sulfate, and it gives the E value for that, and then asks for the sufficient quantity of sodium chloride to make an isotonic solution. And we're adding enough water to give 30 milliliters of total solution. So we'll approach this problem the same way that we did in the picture we just looked at, where step 1 is to determine how much sodium chloride would be needed to make the entire volume isotonic, just using sodium chloride alone. So that calculation looks like this one, similar to what we did for determining how many grams of sodium chloride would be needed to make 1 liter of isotonic solution. Same kind of calculation. We use the isotonic concentration of sodium chloride, and we ask how many grams of sodium chloride would be needed to make 30 milliliters isotonic. So we cross multiply, and X is 0.27 grams. And now we need to account for the contribution of particles from the other ingredient, which is ephedrine sulfate. And we can do that using its E value. Its E value is 0.23, and that means there are 0.23 grams sodium chloride for every gram of ephedrine sulfate. And the prescription says that we have 0.35 grams of ephedrine sulfate. So we'll put that here and ask how many grams of sodium chloride that represents in solution. So cross multiplying, we get X is equal to 0.0805 grams sodium chloride. That's what's represented by the ephedrine sulfate. So if we subtract the amount of sodium chloride needed to make the entire volume isotonic, and subtract from that the amount of sodium chloride represented by the ephedrine sulfate ingredient, that means that we should really only combine 0.1895 grams sodium chloride with the ephedrine sulfate to get the total isotonic number of particles. The final step is just to convert the number of grams that need to be added into milligrams, noting that there's 1,000 milligrams per gram. That gives us 189.5 milligrams sodium chloride to add. So we'll use this quantity of NaCl, we'll use this quantity of ephedrine sulfate, we'll add water up to 30 mils, and we have our isotonic solution. In the next problem, we ask how many milligrams boric acid should be used in this prescription. This time the prescription, even though it still uses ephedrine sulfate, it now gives a concentration of ephedrine sulfate. So we want a 2% solution of that rather than just a mass. And this time the prescription also specifies using boric acid to make the solution isotonic. So we'll put a quantity sufficient of boric acid in there instead of sodium chloride. And then our total solution volume, we'll add enough water to get to 50 milliliters. Step 1, of course, is to determine how many grams sodium chloride it would take to make the entire prescription volume isotonic using sodium chloride only. So here's the isotonic concentration of sodium chloride. How many grams would it take to make 50 mils isotonic? We cross multiply and see that 0.45 grams NaCl would be required. In the next step, we account for the ephedrine sulfate contribution. So we have a concentration this time. That means that we have to find the amount first using the total quantity and the concentration. So concentration is 2%, 2 grams per 100 mil. How many grams are in 50 mil? We cross multiply and see that the prescription will contain 1 gram of ephedrine sulfate. And now we account for its contribution to the particle total by using its E value, which is 0.23 grams NaCl for every 1 gram of ephedrine sulfate. So that 1 gram represents 0.23 grams sodium chloride in solution. All right, so we subtract from the total amount of NaCl that would be required to make the entire 50 mils isotonic. We subtract out the contribution of the ephedrine sulfate from that and see that we actually only need to add 0.22 grams sodium chloride to the ephedrine sulfate to get the isotonic amount. Okay, so 0.22 grams NaCl are required. But we want to use boric acid now. And so if we want to use something else to make the solution isotonic, we can use the E value for that something else, because that just converts us between grams of sodium chloride and grams of the other salt. So if we need 0.22 grams sodium chloride, we can find how many grams of boric acid that represents by using the E value of boric acid, 0.52 grams of NaCl for every 1 gram boric acid. We cross multiply, and that tells us that we would use 0.423 grams of boric acid. That's what's the same as the 0.22 grams of NaCl. And then convert that to milligrams. 423 milligrams boric acid should be added. Okay, so that's the process. Go ahead and try using this process on these two prescriptions that you need to make isotonic.